Okay, this is probably about the third time I've tried to do this, but my kids keep talking to me. So, I am going to try to start. We're going to do 10-2, measuring angles and arcs. This is on page 706 if you need it. All right, so for 10-2, we're going to do measuring angles and arcs. What we're first going to talk about is if I just have a circle. Okay, we're going to have an angle in this circle. And this is going to be circle B. And on the edges here, I'm going to have A and C. Okay, so what this looks like is if I needed to name this circle, it would be circle B. Okay, we always do that dot in it. If I wanted to measure the central angle is ABC, angle ABC. If I wanted to measure it and have a number with it, I would usually use like a little M. So that would read the measure of angle ABC. B is right here in the middle, which is the same as the name of the circle. So make sure we get that whatever one is in the middle of our angle as well. Okay, so this is the name of the central angle here is angle ABC. We're going to say he looks about like 120 degrees. I don't know if that's 100% right. Okay, so I have 120 degrees. And the other thing that we're going to talk about is we could also have an arc. So arcs, okay, so an arc would be from here to here. We're talking about the same measurement, it's going to have the same value for the number part of it, but I would do it differently. I would write the measure of arc AC. So it'd have like a little curvy line. So remember how sometimes we would have like line AC and it'd have a flat line? So this would be for a line. For an arc, it's going to be a curvy line with an AC. So I would say the measure of arc AC is also equal to 120 degrees. So this piece out here is 120 degrees. Okay, the measure of the central angle and the measure of the arc are the same. Okay, so if I was putting it on here, so if I wanted to mark a central angle would usually be marked right here. That was usually marked, hopefully you guys got that off of your IXL. So this guy is 120 degrees. And this guy out here is also 120 degrees. So those are the two different ways to talk about things. We're just usually not really separating them that much since they do have the same measurement. Okay, so all arcs and all central angles must add up in a circle, must add up to how many degrees are in a circle? Up, we're going to scribble that out. We're going to add up to 360 degrees. Okay, so how many degrees are in a circle? 360. How many degrees are in the central angles parts? 360. Okay, so sometimes you can have multiple angles in there. So maybe I could have, let's say this angle over here is 130 degrees. This has a little square guy down here. This is an F in the middle. So if I wanted to name this circle, I would do circle F. This is a G, H, J. And over here, I want to find this angle. Okay, this angle is X. So looking at this circle, your work would include being like, oh, what is this angle over here? And you're going to be like, oh, yeah, that's 90. There's not a lot of stuff to show. I really appreciate it if you guys show your pictures with everything. And I would do 130 degrees plus 90 degrees plus X degrees equals 360 degrees. Okay, so 130 plus 90 is 220 degrees plus x degrees equals 360. You guys are probably really not going to show this much work, are you? So minus 220 degrees. Okay, you probably really don't need to show your degree signs all the time, but we might as well. Okay, so 6 minus 2 is 40. 3 minus 2 is 1. I should have 140 degrees over here for this guy. Okay, that would be the amount of work you would need to show for finding the measure of central angles. I could give you the same amount of stuff, and I could write it instead of out here, I could have the stuff written out here, and I could have 130 degrees over here, and then I could have an X over here, and then I could say, find the measure of GJ with an arc sign on top. Okay, I would do the same amount of work. I would be like, whoa, 130 plus 90, because we still recognize this over here. Plus X equals 360. You're not doing anything different, whether it's a central angle or whether it's the arcs. These are the same amount of work. So it could say, the other wording for this one could have been like, find the measure of angle GFJ. Okay, so the other weird thing to think about is if I'm looking at the same circle, ooh, that's not a circle at all. Let's just undo that. Okay, so if I have, pretty much I'm going to try for this similar circle right here. Okay, I'm going to try to make everything the same. Okay, so I have G, I have angle F, I have H, and that doesn't really look like an F. I'm trying to make that actually look like 130 degrees, but it doesn't really want to look like 130 degrees over here. Okay, so if I'm looking at this guy, so we were told this is 130 degrees, and this letter was J. So the other thing that we can think about is if I wanted you to go, I'm going to erase this G so it looks like it's showing up in the right place. Okay, so if I wanted you to go from G straight to J, I want you to do it. So if I say mark GJ, I want you to go in the smallest possible way here. And if you wanted to, we could write the measure of GJ equals, we already found it, it was 140 degrees, right? Okay, so if I wanted you to do this and I just said, hey, where is GJ? You would mark the smallest possible one to get here, okay? Because I want you to think about it. We could go all the way from G, we could go around and go all the way to J like that. But that is called a major arc. The one that I usually want you to think about is a minor arc, okay? A minor arc is the smallest possible way to get to where you need to be. Okay, so if I wanted you to go this outside direction, I use the magic marker, and it's a really fun star colored. Okay, so if I wanted you to go and do the major arc, I really like this pen, it's really pretty. The major arc, I would label it with one extra letter. I would do G, H, J. Do you see where the H came from? The H came from, it had to go through that point. Okay, I could also do semicircles. So we don't have any semicircles here. A semicircle is going to have 180 degrees. It's not Surde circle, that's a CL there. So a semicircle is 180 degrees. And it would be on a different picture. It would be something with straight across, okay? So there's my Pokeball semicircle. Okay, so a semicircle would be like from here to here. Okay, it could also be the other side. it wouldn't really matter much, okay? I really just want to use this pin for something really pretty and see what happens with it. It's so beautiful. All right, for the next question we're going to do, it is about classifying arcs and finding arc measurements. So I don't know what's showing up here. Okay, so I have this picture over here. It is circle R. Okay, so I have an R right here. You can ignore the stuff up here. I just took a picture of the book to put this up here. It says PM is a diameter. I need to change my pen so that it actually works good. I'm trying to get this, okay. I don't know what parts show up for you all the time, so I had something in my way. So it says PM is a diameter. Right there, that's that line. So that should tell you, so because this one has this little arc or this little square over here, that tells us that this piece is 90. Okay, that means this little piece down here is 90 and this big piece up here is 90. If this is a diameter, what does a semicircle angle add up to? So we're like, whoa, that's 180 degrees. If this is 90 and this whole thing is 180 degrees, this piece over here also has to be 90 degrees. Okay, so we're trying to find a few different things. So we have to say identify each as a major arc, a minor arc, or a semicircle. Okay, so MQ. So let's find MQ. MQ is over here looking at this picture on the right side. MQ is definitely not very big and it's not a semicircle. Okay, so right off the bat, it's a minor arc. And then we need to figure out how much everything added up to. We can do a lot of work, or we can say, hey, if PM is a diameter, then this side, this left side is 90 or 180 degrees, and this right side over here is also 180 degrees. Okay, so we can do it in a couple different ways. We can do 90 plus 90 plus 115 plus the angle that we're looking for right now. We're going to call it X equals 360. Okay, I wouldn't usually do that much work. I would usually probably just do, hey, I recognize that this right-hand side is a semicircle. Okay, not all of them might be that, so it might just be a good habit to get into this, okay? So when you add all of these things up, you would subtract 180. So these two things make 180. So I'm going to subtract that right away. And then I'm going to have 115 plus X equals 180. And then I would minus 115. Okay, and I'm going to have X is equal to 65 degrees. So I have two answers. I have minor arc and 65 degrees. Okay, the next one is MNP. MNP, we've already talked about it. MNP, because PM is a diameter, which it tells us somewhere that this is a semicircle. So a diameter is always going to make a semicircle. So a semicircle. And a semicircle is always going to be equal to 180 degrees, and we don't need to do a lot of work for that. MNQ. MNQ is a bigger guy. So MNQ, let me do a different color for MNQ. I love the space marker, but I won't use the space marker. So MNQ, I need to go all the way. It's okay if I go through another letter when I accidentally hit P. Okay, what does this guy look like? It looks like it's everything but this one that we already found. Okay, so it's helpful to find all the other pieces. Okay, if we know, so MNQ is the major arc. If we have already found the minor arc, we are just going to do 360 minus the minor arc. Okay, this works for both directions. If you had found the major arc first, we would have been subtracting that. Okay, so we're going to do 360 minus 65 degrees. Okay, so 360 minus 65 is going to be 295 degrees. Okay, so a major arc is always bigger than 180 degrees, and a minor arc is always less than 180 degrees. Okay, so you can try to remember that for how to name them. Okay, and then the next thing we're going to do is we're going to be given a graph, a circle graph with percentages. Okay, so the main thing for you to remember is that the total degrees is 360. 360 degrees. So what we need to remember is that we are going to be finding the percentage of 360 degrees. So if I wanted you to find the measure of arc CD. Okay, so CD, so we're going to come over here and we're going to find CD. And we're going to be like, hey, where is, you're just going to do the, after you find it, you're going to be like, whoa, that's a minor arc. If you have to fill that out, you might not have to fill out minor arc. And the only thing that you really have to do is you're going to be like, whoa, I need to take 18% times 360. Okay, but we always need to change percentages into decimals. So what you're really going to have is 0.18 times 360. I'm using parentheses. You can use multiplication symbols, whatever. Just make sure you get this typed into your calculator correctly. So not too much to type into your calculator. As you type that in, you do 0.18 times 360. So that is how you type it in. Sorry, my screen went away. And what you're going to have is you're going to have 64.8 degrees. So there's a few other ones that we can find. So you can find, hey, what's the measure of angle or of arc BC? So let's go over here and find BC. And we're like, hey, that's also 18%. We do not need to do more work. So this angle right here, we already figured that was 64.8 degrees. Okay, this thing right here is also 64.8. You do not need to do more work than you need to, okay? You don't need to remultiply this. You're just going to be like, whoa, I have another 18 degrees or 18%. And that's going to be 64.8 degrees. Okay, so if I needed to find another one, measure of arc EF, measure of arc EF. So we come over here and we find E and F. And we're like, hey, that's 14%, but we're going to change 14% to a decimal right away. So we have 14 times 360. Okay, so if we do 0.14 times 360, okay, we're going to get 50.4. Okay, that's degrees. Okay, and that should be the amount of work you have to do. If you were to figure out all of these things, all of your angles would add up to 360. Okay, we can add arcs just like we can add angles. And then we have one more thing that's a little bit different for you. Okay, so what that's going to look like is you are actually going to take the measurement of the arc. Okay, so all we've been finding is what we say the arc measurement, but we are going to actually find the arc length now. Okay, so this would be like if this was a gear on a motorcycle or a bicycle is what I was really thinking to say. Okay, so this is X degrees. Okay, again, if I was measuring out here, this would also be X degrees. If I wanted the degrees, what I'm actually going to ask you for is if you took a ruler and put your ruler around the outside of this piece, what would it actually be? Okay, so R is for radius. Okay, L is for length. Okay, and what I want you guys to think about it, how I want you guys to think about it is that we are finding a piece of the circumference. We're going to find a certain percentage of the circumference. Okay, so our circumference is the, whoops, I spelled that wrong. Circumference. The circumference is the linear measurement around the entire outside of the circle. Okay, so around the outside of the circle, we usually have circumference equals 2 pi r, or remember we used the different one yesterday that was just d pi. Okay, but what that would be the entire distance around the circle. I don't know, whoa, my pen is not going in the right places. Okay, so that would be the entire distance around the circle. But I only want one small portion of this, okay? So I only want this piece right here. Okay, so what we're gonna do is we're gonna multiply that by the angle over 360. Okay, so either one of my formulas is fine. I'm gonna have my angle over 360. This piece right here is gonna multiply it by the percentage that we were just doing. Okay, so the other way we can think about this formula is that it could be a proportion. So these are your two equations that you can use. It's not quite circumference anymore. Usually it's going to be L. So like you have L equals 2 pi r times x over 360. This is what I'm going to use. We could also use the same thing. So L for length. Sometimes you see different equations that use S. Okay. So when we do this, we'll be given a problem like this. It'll say find the length of ZY. It'll say something along the lines of round to the nearest tenth. Don't whine, dog. And then you'll just be asked to go through this, okay? So we'll have L for length is equal to 2 pi r. So 2 pi r is 4 inches. Okay, so this is my r. This is my radius. So times 4 times my angle, 75 degrees over 360 degrees. Okay, you could probably just type this straight into a line in your calculator. So as I do that, you can do, so 2, it doesn't matter if you use the pi button or the 3.14. You can type in either way. And then just at the end, divide by 360. Just get that all in there. And you're going to have L equals, so this is a piece you're doing in your calculator, 5.235. But the part that you can't read, it goes on, is that we're going to round this to 5.24. And then it says inches, so we're going to do inches. Okay, it's not inches squared, it's just regular inches. So this, if this were like life size, that would be 5 inches, 5.24 inches.